8.2 is graphs of functions. We're going to determine how to look at a graph and determine if it's the graph of a function or not the graph of a function. The easiest way to do that is using the vertical line test. The vertical line test is where you draw a vertical line, compare it to your graph, run it across your graph, and see if your graph ever crosses any vertical line more than one time. If it does cross a vertical line more than once, you're failing the vertical line test. So let me show you what I mean. Here I'm going to just draw a nice big green vertical line. If I take this green line and run it across my graph, and for the record, this blue piece here is the graph. This whole plane, that's the plane, the xy plane, but this is the actual graph. If I take my line and run it across the graph, if this vertical line ever hits the graph more than one time, it is not a function. Since my vertical line never hits this blue graph more than once, this is a function. My green line also never hits this purple line more than once. There's some curve to it, but that's okay. My green line never hits the graph more than once. It is also a function. Remember, a function is whenever one input goes to only one output. Well, inputs are x values and outputs are y values. So like here, the input 1 is going only to 3. And here the input 5 is going only to 4. So it's a function because each input is going to only one output. If we go to this third graph is not passing the vertical line test right here. I hit the graph more than one time. I hit it 1, 2, 3 times. So I'm hitting the vertical line. So the vertical line is hitting the graph more than once. That makes it not a function. Because if I were to plug something in for x, like say I plugged in 0 for x, if x was 0, if the input is 0, the output could be 1 or 3 or -6. And there's 3 possible outcomes from an input of 0, which makes it not a function. It's okay to not be a function, we just know it's not a functional relationship. So that's the vertical line test to determine if something is or is not a function. This one is not a function. It's failing the vertical line test. Another useful thing from a graph is finding the domain and the range. I'm going to keep using this green vertical line, but I'm no longer doing the vertical line test. I'm now checking for the domain. And you can do this just kind of quickly mentally without using a vertical line, but I like to use it. I think about it like it's one of those green lines on a copy machine, like a scanner or something. What happens is, pretend like this right here, all this is a sheet of paper, and I'm going to run copies of it. Well, I put it on the copy machine, and this light goes and scans across it. And it's shining light up through the paper. And wherever it detects ink, because the light gets reflected, wherever it detects ink, it sends a message to the printer to like put ink at that coordinate, at that point. And so a copier works in its basic sense, if I understand correctly. Well, as I'm scanning, starting here at like -9, -10, I scan to the right. I'm not hitting the graph, not hitting the graph, not hitting the graph. And right now I'm going to find the domain. Okay, domain means the x values. So right now I'm checking the x values. Well, the first x value that my graph hits is -5. Right here at -5, there's an x value that my graph hits. And I keep on having x values everywhere, 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 until I get way out here to 7. The x value down here is 7. So this has a domain that goes from -5 to 7, with everything in between. If it didn't have everything in between, I would list out the points, like -5 to 1, 6, whatever they were. But this has everything in between -5 to 7. And we don't want to write it this way. You know, a lot of you think of this as like -5 to 7. The dash means through. But that means -5 minus 7, right? That's -12. That's not very helpful. It's not -5 to 7 in that sense, though, so we have to write it in some special math forms, of course. One of those special math forms is called interval notation. Interval notation means it's going from -5 to 7. That's what that means. Everything between -5 and 7 using those brackets. The other way to write it is what's called set builder notation, which would be the wing bracket means x, or set of, sorry, wing bracket means set of. The set of all numbers x such that, that vertical line means such that -5 is less than or equal to x, which is less than or equal to 7. I much prefer interval notation to set builder notation, but you're going to be familiar with both, especially if you're going to be doing the College Now credit. So I'll do domain again before I jump down to range. Domain is the x values. I'm not hitting the x values here, but I start at -5, and I keep hitting x values all the way up here till 6. That open circle is supposed to be on 6. It's kind of missing. Pretend like it's on 6. This has x values from -5 to 6. So So I'm going to say it's going from -5 to 6, but we don't actually include the 6 because the 6 has an open circle on it. So this is like everything from -5 up to like 5.99999, but not actually 6. The open circle means everything up to 6, but not including it, and that's what this parenthesis means. That parenthesis right there is a signal that we're not including the 6. It's -5 to 6. In set builder notation, it would be the set of all numbers x such that -5 is less than or equal to x, which is less than 6. My x's are getting poor. Not less than or equal to 6, just less than 6. This third one's not a function, but it still has a domain and a range. You'll notice this has an arrow pointing this way forever, and this has an arrow pointing this way forever, which means that at no point am I not hitting the graph. Even way out here, the arrow is pointing towards it. This vertical line is hitting the graph everywhere at some point. So the domain is all real numbers. It's all real numbers. To write that in set builder notation, you always use parentheses for infinity. It's from -infinity to infinity. And sorry, that was interval notation. I'm not sure what I said. That was interval notation. For set builder notation, it's x such that x is in the set, and that little backwards e means in the set of all real numbers. We'll talk a lot about these forms of notation in class. You'll get very familiar with them, actually, don't worry. Next, let's do range. Range means the y values. Now, instead of scrolling left to right, I'm going to scroll bottom to top. My green line just hid from me. Starting down here, I am not hitting the graph because there's no arrows. I scroll up, I start hitting the graph when the y value is 0, right here. This is a y value of 0, and it continues up, 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 up until a y value of 6. So the range of this goes from 0 to 6. X such that 0 is less than or equal to x, which is less than or equal to 6. Let's do the range of the next one. I'm not hitting the graph at -8. I'm not hitting the graph at -7 or -6. At -5, I start hitting the graph. Kind of. Not actually at -5, but everything right above -5, because that open circle means not including -5. And then up, 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 hit the graph, 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 until 4. So the range of this is going from -5, not including the -5, to 4, including the 4. The set of all numbers x such that -5 is less than x, which is less than or equal to -4. This third one is pointing up forever and pointing kind of down forever. So the range and the domain are the same. It's all real numbers. I would just write those things down again. So domain is a set of all x values. Range is a set of all y values. We'll talk about these a lot more, but there's the introduction. We can also find inputs and outputs from a graph. This is saying the x value is 2. I'm going to do f of 2. If I plug in a 2 for x, what do I get out for y? I get out a 3, so f of 2 is 3. Okay, this is the input. The input is 2. I go to 2 on the x-axis and see what I get out on the y-axis. So like for f of -5, well, -5 is here. The x value is -5. The y value is 0. That's -5, 0. f of -8 doesn't appear anywhere, so that's undefined. Now I know I'm going through this quickly, so I'll make up an example here. See if you can determine what f of 5 is. Okay, pause it. Determine f of 5 based on the graph. The input is 5, so I go to 5 on the x-axis and I check and see what's the y-axis value. 4. This is the point. 5, 4. Input was 5, output was 4. Over here, same game. If f of 0, if f is 0, we get out 3. If f is 1, we get out 4. If f is 6, that is actually undefined. It looks like it should be -5, but there's an open circle there, so it is undefined. We don't have any value there. Inputs and outputs. I'll do one more, maybe pause and try this one. What is f of... What else should I do? 2. f of -2. Or f of 2. Pause it and try those. -2, 0. 2, 3. I hope that's helpful. Have a nice day. Thank you.